Okay, so this warm-up is on page 27 in your packet. We're going to pause the video here for you to try all three questions. The quiz tomorrow is going to cover interpreting graphs, linear functions, the cost, revenue, and profit, like this warm-up, and I can't remember off the top of my head if it has piecewise on there or not. It might have one simple piecewise question on there. Okay, so try this warm-up. Okay, so for A, find the revenue and the cost if you are producing 500 units. Oops. So we're going to plug in 500. And you should get a cost of $11,000. And then the revenue of 500 is $6,000. Does the company make a profit? No. The revenue is smaller than the cost. Oh, that's annoying. Okay, for B, find the revenue and the cost if the company is producing 5,000 units. Okay, so let's plug in 5,000. So the cost is going to be $56,000, and the revenue is $60,000. So because the revenue is now greater than the cost, the company does make a profit. For the break-even point, we're going to set the revenue equal to cost and solve. So when will 6,000 plus 10Q equal 12Q? Let's subtract the 10Q to the right. Divide by 2. So 3,000 items, or units. So we'll write 3,000 units. Okay, so today we're going to focus on piecewise functions. We will pause the video here for you to copy down the definition. And a piecewise function is in pieces. So if I look at number 1, this top piece, this subfunction, has a certain interval or subdomain of x is less than or equal to 1. And then this subfunction on the bottom has a subdomain of x is greater than 1. So let's evaluate for all these values. So it's like matching. When they give us f of 1, we have to figure out which piece, the top or the bottom, contains 1. So if I look here, x is less than or equal to 1, that 1 is in that subdomain. So substituting that in, we get -3. So now for -2, that is in the top subfunction. -2 is less than or equal to -1. So that's 4 minus 1, we get 3. So now 4 is in the bottom subfunction and subdomain. So we're going to plug that one into the bottom. So let's see, that's -16 plus 12 plus 5. So that is 1. And then lastly, 0. Well, 0 is less than 1, so that goes back to the top one. And when we plug in 0, we'll get -1. Okay, so sketching the graph. A compound function, the reason I have this underlined is it is the same way of saying a piecewise function. So we have two choices. You can use your graphing calculator. I don't have one while making this video that I can put on the screen, but what you could do with the graphing calculator is put this in Y1, look at your table of values for less than 0, plot some points and connect the graph. Then you're going to put x plus 2 into Y1, look at the table of values for more than 0, and plot the graph. So I'm actually going to do something similar, but by hand. So for the -x squared plus 1, we want less than 0. I still have to plug in 0. because the 0, when I plug that in and I get 1, I have to put an open point at 0, 1. And the reason for that is because we need to include the values really, really, really close to 0, but not quite 0. So by putting the open circle and then connecting that to the rest of the graph, that shows we want really, really, really close to 0, but not equal. So now when I plug in -1, I get 0. When I plug in -2, let's see, that's -4 plus 1. And then -3, that's -9 plus 1. All right, so that gives me a good enough do I have 8 points here? 1, 2, 3, 4, 5, 6, 7. Nope. So I know x squared, it's a parabola, so it's going to have the curvy shape, and it's opening down because of the negative. So now let's graph the x plus 2. We want greater than or equal to 0. So plotting those points. And it's a ray. And there's our graph. Okay, so the next kind of function is the step function. It's also known as the greatest integer function. We'll pause the video here for you to copy down the definition. One of the things that students have a harder time remembering is these symbols here mean it's the greatest integer function. So what the step or the greatest integer function does is it takes any value for x and it makes the y the integer less than or equal to that. So let's visualize. I like baking. We use a lot of flour when we bake. So how many 1-pound containers can be completely filled by 5 pounds of flour? It's going to be 5 containers. How many containers can be completely filled by 5.1 pounds? Still just 5. How many can be completely filled with 5.2? 5.8, 5.9. Even if I have 5.99 pounds, I can only still completely fill 5. As soon as I hit 6 pounds, we get to 6 containers. So what that does is this is the greatest integer function. It takes the value to the integer or the positive or negative whole number less than what you plugged in. So that's why all of these values rounded down to 5. So now here's a graph. If we want to think, let's start at 0. So 0, 0, and then 0.1 or 0.2 all the way up to 0.9 is still going to be 0. But as soon as I hit 1, I'm equal at 1. So I left an open circle down here at 0, 1, but I have a closed circle at 1, 1. And it's going to continue to the left in that pattern. We can take that backwards to the, I'm sorry, I said that backwards to begin with. It continues to the right in that pattern. Now if we take it backwards to the left, sorry, it's hard to color these points in on my iPad. Make it bigger. And there is our greatest integer function. Okay, so for number 5, sketch the following step function using this grid above. So what is a good y scale? Let's see, we go from 8 to 20. And we have 10 boxes, so let's go by 2s. So this is money on the y-axis, or cost, and we'll have ounces. So we'll go by 1s on the x-axis, Uh-oh. Nope. Sorry, because we have to get up to 16 ounces. So let's count that by 2s as well. Start over. Ounces, we'll go by 2s. Now it fits, and then our cost and money will also go by 2s. And we're going to have to estimate, because $8.50, well, we'll just put that really close to the $8. So let's see, it's $8.50 from 0 to 2, not including 0 or 2. So that's here to here. And then it's $9.75. So let's say almost $10 from 2 to 4. Your open circles don't have to be as exaggerated as mine. And then it's $12 from 4, including 4, but not including 6. $13 from 6 to 8. So let's go right in the middle here. $15.50 from 8 to 10. 17. 18. Let's get squishy here at the top. And then 19.25. Okay. Whew. This starts your homework. So we will pause it here and get started. It's page 29, 30, front and back, all of it. For these graphs, definitely use your calculator. I even see this, e to the x. So use your calculator to help you sketch those pieces.